This video is on exercise 1D of A-level further maths core 1 textbook. So, in order to answer the first two questions, we should be able to use the concept of complex conjugates. And all we have to know here is that, let's say Z is a complex number, which is A plus BI. Then the complex conjugate of Z, which we normally show this with Z star, is A minus BI. Basically, you negate the imaginary term, and that's it. So, and then this allows us to do some very interesting stuff in different aspects of when it comes to working with complex numbers in different areas. We can use this concept. So now this is an introduction, so there's some very basic questions. So in question A, basically we have to question 1, we have to find the complex conjugate of each of these complex numbers. So for example, A, which is Z is equal to 8 plus 2i, then the complex conjugate of that is 8 minus 2i. So as simple as that. And this principle just is the same for all the complex numbers. So in B we have 6 plus 5i. In C we have 2/3 plus a half I. And finally in D we have root 5 minus I root 10. So yeah, that's it for the first question, which is a very simple question. Now let's do the second one. So now for each of these complex numbers we have to find Z plus Z star and Z times Z star. So basically we want to find the sum and the product of a pair of complex conjugates. So now for part A, so basically Z plus Z star is equal to 6 minus 3i, which is Z, then plus 6 plus 3i. So remember that this one is the complex conjugate of the first one, or you can also say that the other way around. So now the sum of this is just 12. So the imaginary part will be gone because they cancel each other out. Now for the second bit, which is basically multiplying the two complex conjugates, so you have 6 minus 3i times 6 plus 3i, and as usual this is just like the usual expansion. So 6 times 6 36, 6 times 3i 18i, then we have minus 18i, and finally we get minus 9i squared. But we know that I squared is minus 1, so this gives us minus 1 minus 9, which is plus 9. And now again the imaginary parts will be gone. Then we have 36 plus 9, which is 45. In part B, so the complex number that we are given is 10 plus 5i. So then here we have 10 plus 5i plus 10 minus 5i. That's the conjugate of that. And now this gives us 20. That's it. So then we should multiply them again. It's about expanding the brackets really. So sorry, the second complex number is 10 minus 5, and now so it's 100 minus 50i plus 50i, and finally minus 25i squared, which again gives us just plus 25, and we get 125. C, Z is equal to 3 over 4 plus 1 over 4i. So we have 3 over 4 plus a quarter of I, then plus 3 over 4 minus a quarter of I, and then we get 6 over 4. And now we should multiply them. So 3 over 4 plus a quarter of I, then 3 over 4 minus a quarter of I. And again, we should just expand this bracket. So we get 9 over 16, then we get minus 3I over 16 plus 3I over 16, and finally minus I squared over 16. Okay, so we have 9 over 16, then these two terms add up to 0, then minus I squared over 16 is just basically minus 1 over 16, which is 1 over 16. And we get 10 over 16. And finally the last one. So we have root 5 minus 3I root 5 plus root 5 plus 3I root 5. So we get 2 root 5. And now for the multiplication bit, we have root 5 minus 3I root 5 times root 5 plus 3I root 5. And then root 5 times root 5 is 5. Then we get, so here we get 3I times 5, because, root 5 times 3I root 5, the two root 5s, cancel each other out, and basically you will get just 5, and then 5 times 3I. And the same thing happens for this term times this term, but, with just a negative sign. So we have minus 5 times 3I, and finally for the last one, so this term times this term, we have minus 9I squared times 5. Now let's simplify this. So 5 plus 15I minus 15I. Then here, so I squared is just minus 1, then minus 1 times minus 9 is 9, 9 times 5 is 45, and we get 50. Right, so that's it for this video. I hope this helps. So make sure to subscribe to my channel for more videos, so you won't miss the future videos. Good luck.